Hi everyone, I'm Nate from the Swift team at Apple. Let's chat a bit about an optimization testing strategy we recently started using. So consider the following scenario. You're writing a new optimization pass, and it relies on some utility you're adding. And you'd like to test that utility in isolation in the context of some particular function. And you'd like to be able to pick out specific elements from the IR function to run your utility on. In this example, we're adding a replace all uses with utility, and we'd like to test it in the context of this function, handoff. Specifically, we'd like to replace all uses of C2 with C. So one thing that our solution needs is to allow you to pick out particular elements from the IR function. And the other thing is to look like a regular optimizer test. You provide some input IR function, and you file check some output. So in this case, we want to use FileCheck to verify that the applies use of C2 is now a use of C. Okay, so these constraints illustrate why a couple of existing approaches aren't quite suitable. Utility passes, for example, sort of run on everything. And that's perfect if you want to compute an invariant for every instruction in an IR function. But for something like replace all uses with, it's not quite appropriate. Like, what would you replace? Now, a unit test, on the other hand, would allow you to invoke your utility in any way you'd like. But writing such a unit test in the context of an IR function is very different from writing a standard optimizer test. You'd be writing source code that somehow ingests your function, digs out the elements it cares about, calls your utility, and then makes assertions about the result. So here's the solution we adopted in Swift. In the IR function, we add a specify test instruction, which says which test to run and which elements from the IR function to run it on. Then in our compiler source code, we add an instance of function test that invokes the utility with the elements specified by the specify test instruction. Let's walk through this example in a bit more detail. In our test file, we have the IR function, handoff, containing the specify test instruction that says the test named RAUW should be run with the elements C2 and C, both of which are values. Now over in our compiler source code, we define a function test named RAUW, and its definition is this lambda. Now the lambda takes an argument struct, which is sort of the test view on the elements from the IR function. And in this case, both of those elements are values, so the test takes out each value and passes them along to our utility, replace all uses with. Then you print out some test-specific info. In this case, just printing out the function. The last step is in our test file, we have FileCheck to verify what was printed. Now this approach has some of the benefits of a unit test and some of the benefits of a utility pass. Like a utility pass, you get to cut compiler code that invokes your utility just once. And then you write as many input IR functions as you'd like. And similar to a unit test, in each of those IR functions, you get to pick out the elements you'd like to run your utility on. So at this point, we've only looked at an IR function with a single specify test instruction that only picked out values. But that's not all this approach can do. You can have multiple specify test instructions, and maybe they invoke different tests. And moreover, you can pick out different elements than just values from the IR function. Not only that, but you can pick out those elements with reference to the location of the specify test instruction inside the function. So you can say the previous instruction, its first operand, or the block containing the specify test instruction, or even the function after this one in the module. So hopefully at this point you're thinking, that looks pretty handy, how can I use it? If you're contributing to Swift, then good news, you can go use it today. For LLVM, I have an implementation in progress. For other projects, I absolutely encourage you to adopt this approach. If you'd like to chat more about this, please find me. All right, thanks for your attention.